Hello everyone, this is lab number 6. In this lab session we're going to study the logarithmic and anti-logarithmic amplifiers, or in short log and antilog amplifiers. Basically the main difference from the previous amplifier we studied is that now instead of capacitors or just resistor we're also gonna use the diodes. So instead of the feedback resistor that we used before, we're gonna put a diode. Diode you should already know and maybe already familiar with. Diode is a special device that can pass only positive or negative signals. So cathode, each diode has anode and cathode. Anode is a positive pin, positive polarity of the pin of the diode, and cathode is negative. So in your packages you should find the diode, and in your diode you're gonna have like a black line. So from right side, if you find the black line, it means this right side of the pin of the diode is negative. So make sure that connect this black line to the cathode and the opposite line to the anode. So let's try first see how the logarithmic or log amplifier is working. Basically what you have to do, you have to set a signal generator, connect two BNC cables to compare input and output, set your signal generator to 100 Hz, and this time make sure that you don't have negative signal, since diode doesn't correlate, doesn't work well with the negative part, so it's just gonna distort the signal and doesn't allow to pass the negative part. So make sure that your signal is starting from 0 to 1, not like previously signal is sort of from negative to plus, but make sure that your signal is from 0 to 1. Okay, so the signal from signal generator goes to 1K resistor, and the feedback line is going to be connected to the cathode. Make sure that from output it goes to the cathode, and the anode goes to the input of the amplifier, okay? And plus goes to the ground. And set your signal generator to 10 or 15 or 20, like change it accordingly. If you're gonna have like clipping, increase the biasing up to 20. So what we have to do, what we have to actually obtain, the blue line is this input signal. So we feeding the sinusoidal signal of 1 volt from 0 to 1, and in output we're getting this yellow line. So basically what this logarithmic amplifier is doing is actually suppress big signal changes. And as we can see, when sinusoidal line is increasing, it suppresses changes. So we don't have any changes. Only up to when it reaches the maximum, then it goes up exponential and comes back. Basically the logarithm is it's a function that relates to an exponential function. So basically we're going to have exponential behavior here. Try to repeat and obtain the same behavior, and try to actually explain what you actually obtain and how this logarithmic amplifier is working. Now we're gonna see how to build antilog amplifier. Structure is the same, but just we need to swap. So now in this time the diode goes to the input, so the signal from the signal generator goes directly to the anode side or positive side of the diode, and then it goes to the negative input of the amplifier, and as a feedback we're gonna have 1K resistor. So 1K resistor feedback, and for input from the signal generator we connecting the diode. So signal generator goes to positive and then goes to the amplifier. Signal generator, the biasing is the same. So now we're gonna see the opposite behavior. So as previously, the blue line is the input, and as we can see, we have like a negative signal. We don't have the positive part within output. The reason is why it's happening is that, first of all, we have like inverting type of OpAmp, so it's gonna invert signal, and also it's anti-log topology. So anti-log amplifier is gonna actually exponentially increase the small signals. So as you can see, previously we had this small signal, and it's exponentially increase the signal. So this is how its anti-log amplifier is working. So try to repeat the same structure, anti-log, and try to obtain these results, and also try to explain how anti-log amplifier is working, and actually what's the difference between the log amplifier and anti-log amplifier. Because log amplifier is when we have the diode in the feedback line, in feedback loop, and anti-lock amplifier when we have a diode as input, and the resistor is the feedback loop line. Okay, so repeat the same structure, record everything, and explain the difference between a lock and anti-lock amplifier.